So very good evening to one and all present here. Today we are going to see about engineering mechanics. So first let us start with the basic concept of engineering mechanics. So it is one of the discipline in engineering science. Engineering mechanics is the branch of engineering science primarily deals on different real world practical engineering problems with the application of mathematics and allied physics knowledge as a primary input to tackle different type of structural, say, civil mechanical engineering problems. So further, the engineering mechanics can be divided into two types, statics and dynamics. So statics take a rigid body subject to rest. There is no motion. So under resting condition, what are the types of forces which is applied on the rigid object? When you take dynamics, the same rigid body subject to moving condition, that is motion. So apply the force according to the movement of the direction of object. So then we call that study as dynamics. So these are the two different branches in engineering mechanics. Further, the term dynamics can be divided into two sub-branches, kinetics and kinematics. So what is the deviation difference in concept between the two? So if you consider the impact of force on a moving body, then we call that as a kinetics, a force due to acceleration. So kinematics here, without taking into account the force as a major factor, the force will not be considered, but we will study the motion of an object due to dynamic condition. So this is kinematics. So without considering the force is kinematics, whereas kinetics deals with the study of forces on a moving object. Let us go to the concept of force in mechanics. So what do you mean by a force generally? How to define the force? So here comes the classical meaning, the definition for the force. It is a term which used to describe an object which is subject to push or pull resulting due to the interaction. So you take two objects. When two bodies are subject to interaction and that is experienced by a push or pull, there occurs a force. So due to that applied force, we can able to lift the rigid body. When the interaction becomes zero, there is no longer the impact of force which is continue to occur. So it will be zero, no force will be there if you discontinue the interaction between the two objects. So from this discussion, it is clear that the force generates due to the connectivity or the degree of interaction, interrelationship between the two rigid body that can be lifted with the help of an external aid. Here in this example, rope and the pulley mechanism. With that is the external aid. With that only we are applying the force to move the object from the ground level. So with the introduction of force definition, now we are going to see the system of forces and what are the different types of forces under this topic, system of forces. First, what do you mean by a system of forces? In the earlier slide, we saw about basically simple way, what does the term, the force exactly mean? Now coming to the next information, when a multiple amount of force acting on an object, then we call as a system of the forces and that too simultaneously on a same object. Okay, the force can be described on following characteristics. You say magnitude, direction, point of application, and line of action. These are the four major characteristics to define the force. So this is a simple diagrammatic explanation which is given here. So the system of forces can be understood with this graphical and illustrative picture. So here we can see number of forces which are acting in the same direction or the same plane simultaneously at a point. So now what are the various system of forces that we are going to see in the next slide? So coplanar forces and non-coplanar forces. These are the two categories of system of forces. So in coplanar forces, when all the forces acting on the same plane, on the same region, we call this as a coplanar force or concurrent simultaneous force. The force which acts simultaneously in the same region. Non-coplanar forces. If the line of action of force do not lie in the same plane, then we call as a non-coplanar forces, as shown in the below diagram. So force F1, whose direction is entirely different compared to F2 and F3. All the three forces are not in the same plane, not in the same direction. So with this, the basic introduction, I thank each and every one of you for your kind support. So in the next meeting, we will see the further continuation of engineering mechanics with numerical quantitative problems and also some of the basic law, the working principle in engineering mechanics that also we are going to discuss. So thank you, Ananda, present here. We will meet in the next class.